Kia ora tātou, welcome to this video where we go over rates of reactions, just a very quick introduction, and in following videos we will go into further details about it. So we've got a rate of reaction, so rate we're talking about effectively how quickly something happens in a certain period of time, or how often something happens in a certain period of time, more to the point. So let's say we've got some reactants, we've got a circle, and we have a square, and these two, when they react together, we get the complex compound called circle square. So we've got the reactants on this side here, and the products on this side here. So if these were, the circle and the square were both gases, how would that look if, and then the product was a gas, how would that look in a sort of a reaction chamber? So these squares are supposed to be all the same size, but they are not, but just pretend they are. So let's say we've got the circle reactants, which are zooming around the container, and we've got the square reactants, which are also zooming around in the container. So we have the reactants here. At some stage, and it looks like these are going to collide there, we get the circle and the square colliding together. Ooh. Okay, that wasn't as good as I hoped it would be. So they've collided together, and then what we get as a result is our compound, which is circle square, our product. So what we need for this to happen is that when they collide, there's two ways that this rate of reaction, so the frequency that these successful collisions happen, can be changed. So we can either, if the frequency of collisions increases, then we're going to end up with more products more often, so the rate of the reaction would increase. The other thing is that if we increase the proportion of successful collisions, so what that means is that when these reactants collide, if they collide really slowly, then they won't have enough energy to then turn into products. They would just bounce off each other, you could picture, and they would go back to, they would still be reactants. So the proportion of successful collisions is something that we could increase as well. So if kind of 2 out of 10 collisions result in a product, then that's going to be a slower rate of reaction than if 4 out of 10 of the collisions resulted in a product and they were happening at the same frequency. So the ways that we can change either the frequency of collisions or the proportion of successful collisions, we've got 4 factors that we're going to look into. 3, 4. So the first one is surface area. Surface area, and you would have done this in, it'll be largely a revision of year 11, so it's all good. Surface area. The next one could be concentration. Temperature, and then adding a catalyst. And so this year we might have talked about catalysts last year, but this year it's actually going to be catalysts. This year it's actually going to be tested. STS. There we go. So the surface area and the concentration, they both affect the frequency of collisions. Temperature is special because it affects the frequency of collisions and the proportion of successful collisions. And catalysts, they reduce the amount of energy required for a collision to be successful and result in products. So that talks about the proportion of successful collisions. So that is an introduction to rate of reactions. In the next videos we'll go over one at a time: surface area, concentration, temperature, and catalysts. Once you've got the idea of what's going on, the next thing is to be able to answer an exam question to the level that you would like, so merit or excellence or achieve if that's what you're going for. And that just takes a bit of practice. So in the videos going over these, we'll look at how we'd answer exam questions as well. Thanks for watching this one. Look forward to seeing you for the next 4 videos.